Students, we are discussing plant growth and its development chapter. Yes or no? We are discussing chapter plant growth and its development. In this chapter, go for the next topic, that is a growth rate. What it is? Growth rate. Growth rate, right? Sir, growth rate means nothing but increased growth. Increased growth. Increased growth per unit time. What is the meaning of growth rate, sir? Increased growth per unit time is called as growth rate. It means growth rate can be expressed mathematically. Yes or no? What, sir? Growth rate. Growth rate can be expressed. Growth rate can be expressed mathematically. Is it okay? Now listen this statement. Take a organism. Sir, organism or a part of an organism produces new cells. Yes or no? Sir, in our body every day number of new cells are formed. Yes or no? Right? Sir, organism produces new cells by a variety of ways, by different methods. Organism or part of an organism produces what it produces? New cells. Produces new cells by variety of ways, by different ways. A organism or part of an organism is producing what, sir? New cells. Sir, what is the meaning of growth rate, sir? Growth rate means increased growth per unit time. Yes or no? What is the meaning of growth rate? Increased growth per unit time. It means growth rate shows an increase. Yes or no? Growth rate shows an increase. This increase may be arithmetic or geometric. This increase may be arithmetic or geometric. Therefore, write growth rate. Growth rate shows an increase. Yes or no? It is showing increase in growth, right? Therefore, sir, growth rate shows an increase which may be what, sir? Arithmetic or geometric. Which may be arithmetic or what, sir? Geometric. Is it okay? Go for the first one. Which growth, sir? Arithmetic growth. Which growth, sir? Arithmetic growth, right? Now listen here. Sir, here I am taking one meristematic cell, sir. Which cell this is? Meristematic cell. Sir, what is the meaning of a meristematic cell, sir? The cell which can divide. Yes or no? Sir, this is a meristematic cell. Sir, meristematic cell means the cell which can divide, right? Sir, it undergoes which division, sir? Mitosis. Sir, if one meristematic cell undergoes one mitotic division, if one meristematic cell undergoes one mitotic division, right, then how many daughter cells are obtained? How many daughter cells are obtained? 2 daughter cells are obtained. Yes or no? Sir, this meristematic cell is undergoing which division, sir? It is undergoing mitotic division. Yes or no? It is undergoing which division? Mitotic division. So how many daughter cells are obtained, sir? 2 daughter cells are obtained. How many daughter cells are obtained, sir? 2 daughter cells are obtained. Is it okay? I am indicating daughter cell with DC. Therefore, this is a daughter cell, sir. This is also a daughter cell, sir. Is it okay? Right. Now, sir, this is which cell, sir? Daughter cell. Now, listen this statement. Sir, in these 2 daughter cells, right, one daughter cell retains dividing ability. One daughter cell retains dividing ability. For example, out of these 2, right, what is happening? One daughter cell, for example, this daughter cell retains which abilities are dividing ability. Therefore, one daughter cell retains which abilities are dividing ability. One daughter cell retains dividing ability. So can we call this daughter cell as a meristematic cell? Yes, because it has retained the dividing ability. Therefore, this becomes which cell, sir? Meristematic cell. This becomes meristematic cell. Is this statement okay? Sir, one more cell is left. Yes or no? Sir, this cell undergoes cell differentiation. This cell undergoes what? Cell differentiation. This cell undergoes what, sir? Cell differentiation. Sir, if cell differentiation takes place, which cell is formed, sir? Permanent cell is formed. Yes or no? What is the result of cell differentiation? Permanent cell. Permanent cell, matured cell or a differentiated cell is formed. Yes or no? Right? Now see this statement carefully. See here. Sir, I am taking one meristematic cell. It has undergone one mitotic division. How many daughter cells? 2 daughter cells. Out of 2 daughter cells, one daughter cell retained the dividing ability. It means one daughter cell remains as meristematic cell, whereas the second daughter cell has undergone cell differentiation and produced which cell? Permanent cell. Now you tell me here how many meristematic cells are present? One meristematic cell. Sir, this meristematic cell again divides. How many daughter cells? Again you are going to get 2 daughter cells. Out of 2 daughter cells, one daughter cell retains dividing ability, whereas the next one is converted into which cells are? Permanent cell. Is this statement okay? Right? Therefore, if you take one meristematic cell, on division, it has produced 2 daughter cells. Yes or no? Produced 2 daughter cells. Out of 2 daughter cells, one has changed to permanent cell. Whereas this daughter cell, right, it remains as a meristematic cell. It remained as what, sir? It remained as a meristematic cell. This meristematic cell has again divided. How many cells you are going to get? 2 cells. 2 daughter cells you are going to get. Out of 2 daughter cells, one is becoming what, sir? One is becoming permanent cell. Whereas the second one is continuing as a which cell, sir? It is continuing as a meristematic cell. Is this statements okay? Is it clear? Right. Therefore, which growth we are discussing, sir? Arithmetic growth. In arithmetic growth, what happens, sir? When a meristematic cell divides, out of 2 cells obtained, one daughter cell retains dividing ability and it will be meristematic cell, whereas another daughter cell undergoes cell differentiation and produces a permanent cell. Such type of growth is called as what, sir? Arithmetic growth. Is it okay? Which growth, sir? Arithmetic growth, right? In arithmetic growth, what happened, sir? When a meristematic cell divides, out of two daughter cells obtained, out of two daughter cells obtained one daughter cell retains dividing ability. One daughter cell retains which ability? Dividing ability. It means one daughter cell will be meristematic cell, right? The daughter cell will be meristematic cell, right? Whereas another daughter cell undergoes what, sir? Cell differentiation. Another daughter cell undergoes cell differentiation. Undergoes cell differentiation and produces which cells are permanent, and produces a permanent cell. Is it okay? Therefore another daughter cell, right, it is undergoing cell differentiation, it is producing which cells are permanent cell. Is this statements okay? Sir, this growth is called as what, sir? What is this growth called as? Such growth called as what, sir? Arithmetic growth, right? What is such growth called as, sir? Arithmetic growth. Such growth called as arithmetic growth, right? Sir, root elongating at a constant rate shows arithmetic growth. Root elongating, this statement is important, at a constant rate. Root elongating at a constant rate shows which growth, sir? Arithmetic growth. Root elongating at a constant rate, right, shows which growth, sir? Arithmetic growth. Is it okay? Now, sir, expression for arithmetic growth. What is the expression for arithmetic growth? What is the expression for arithmetic growth, right? LT is equals to L naught plus RT. What is the expression for arithmetic growth? LT is equals to L naught plus RT. Sir, here LT stands for length at time t, whereas L naught stands for length at time 0, right? Whereas R stands for what, sir? R stands for growth rate. R stands for what, sir? Growth rate. Is this statement okay, right? Therefore, sir, what is the expression for arithmetic growth, sir? LT is equals to L naught plus RT. L naught plus RT, right? We are discussing, right, which growth, sir? Arithmetic growth, right? Which growth? Arithmetic growth, right? Sir, for arithmetic growth, right, linear curve is obtained. What is obtained, sir? Linear curve is obtained. Sir, when we are going to get a linear curve, sir? When time is taken on x-axis and length or height of a plant taken on y-axis. See this statement? Sir, we are taking time on x-axis right, length or height of a plant on y-axis, then we are getting which curve for arithmetic growth, sir? We are getting a linear curve. We are getting a linear curve, right? Now see this graph. Sir, this graph is for arithmetic growth. In this graph, we have taken time on x-axis, right, and height of a plant on y-axis. And we got what shaped curve, sir? We got a linear curve. We got a linear curve. Yes or no? Sir, we are taking time on x-axis and height of plant on y-axis. Then we got what shaped curve for arithmetic growth, sir? Linear curve. We got a linear curve for arithmetic growth. Is it arithmetic growth, right? Now go for number 2, geometric growth. Which growth, sir? Geometric growth, right? Geometric growth. Sir, geometric growth is common. Geometric growth is common in unicellular organisms which grow in a nutrient-rich medium. Therefore, which growth? Geometric growth. Geometric growth is common. Geometric growth is common in which organisms, sir? Unicellular organisms. Which organisms? Unicellular organisms. Unicellular organisms which grows in a nutrient. Which grows in what, sir? Which grows in a nutrient rich medium. Which grows in what, sir? Nutrient rich medium. Is this statement okay? Sir, geometric growth is common in which organisms, sir? Organisms which are unicellular and which grow in what, sir? Nutrient rich medium. In most of the systems, this statement is important. In most of the what, sir? Systems. In most of the systems, right, initially growth is slow. In most of the systems, initially growth is slow. Sir, initially how the growth is, sir? Slow. This phase is called as a lag phase, L-A-G. This is called as which phase, sir? Lag phase. Sir, later, initially growth is slow, no doubt. Later what happens means, later growth becomes fast. Later growth becomes what, sir? Fast. Later growth becomes fast. Why, sir? Due to geometric growth. Due to which growth, sir? Geometric growth. This phase is called as log phase, L-O-G, log phase. Sir, L-O-G, log stands for what? Logarithmic. Therefore, log phase is also called as logarithmic phase. It is also called as exponential phase. It is also called as logarithmic phase or what, sir? Exponential phase. Logarithmic phase or exponential phase. Is this statement okay? Sir, in a lag phase, growth is slow. Yes or no? Right. Whereas in log phase, logarithmic phase, exponential phase, growth is how? Fast. Why growth is fast here? Due to geometric growth. Due to which growth, sir? Geometric growth. Now, what is the meaning of geometric growth, sir? Now, listen here. Sir, here I am taking one meristematic cell, sir. Which cell? This is meristematic cell. Sir, meristematic cell means can divide, cannot divide, can divide. A meristematic cell undergoes which division, sir? Mitotic division. Yes or no? Undergoes which division, sir? Mitotic division. Due to mitosis, how many daughter cells are obtained? 2 daughter cells are obtained. How many daughter cells are obtained, sir? 2 daughter cells are obtained. Now we are discussing which growth here? Geometric growth. Sir, these 2 daughter cells retains dividing ability. Both the daughter cells retains which ability? Dividing ability. Retains dividing ability. Sir, how many daughter cells are retaining dividing ability, sir? Both the daughter cells retains dividing ability. So this meristematic divides, produces how many cells? Produces 2 cells. Sir, this also retains dividing ability. So this also divides, produces how many cells? Produces 2 cells. Therefore, one cell when divided, 2 cells are obtained. Both the cells retained dividing ability. It means both are meristematic. When these 2 cells divided, how many cells we got, sir? 4 cells. Sir, when this cell divided, how many cells? 2 cells. Both the cells retains dividing ability. So this meristematic produces 2 cells. This also meristematic produces 2 cells. Sir, retained dividing ability, meristematic. When this divides, we got 2 cells. Yes or no? Sir, these 2 cells retains dividing ability. Therefore, meristematic, meristematic. Sir, when this divides, you are going to get how many cells, sir? 2 cells. When this divides, you are going to get how many cells, sir? 2 cells. Yes or no? Right. Therefore, geometric growth. What is the meaning of geometric growth? When a meristematic cell divides, when a meristematic cell divides, the 2 daughter cells obtained retains dividing ability. That is, both the daughter cells will be meristematic. Both the daughter cells will be meristematic. Is this statement okay? Therefore, what is the statement? When what, sir? When a meristematic cell divides, when a meristematic cell divides, the 2 daughter cells obtained what's her dividing ability. The 2 daughter cells obtained retains dividing ability, right? Yes or no? Retains what's her dividing ability. That is, both the daughter cells, are meristematic. What is this growth called as, sir? Geometric growth. What is this growth called as a geometric growth? Is this statement okay? Right? Therefore, when a meristematic cell is dividing, we got 2 cells. The 2 daughter cells retained which ability, sir? Dividing ability. As they retained dividing ability, now both the daughter cells are meristematic cells. Yes or no? Both the daughter cells are meristematic cells. Such growth is called as which growth? Geometric growth. Due to this geometric growth only, right, in log phase the growth is what, sir? Fast. Is it okay? Right? Now listen this statement. Number 3. Sir, initially growth is slow. We called it as a lag phase. Later growth became fast due to geometric growth. Yes or no? Then later what happens means, it means after log phase. After log phase, what happens means, right, growth again slows down. Growth again what? Slows down. Sir, what again slowed down, sir? Growth. Growth again slows down. Why, sir? Due to limited supply of nutrients. Growth again slows down due to what, sir? Limited. Due to limited supply. Due to limited supply of nutrients. Sir, what is the meaning for this statement, sir? Limited supply of nutrients. See here. Sir, if you take log phase, which growth? Exponential growth. Means growth is fast. So number of cells increased. But number of cells increased, but amount of nutrients goes on decreasing. Because as the number of cells increases, the consumption of nutrients increases. So automatically the supply of nutrients, what happens? Decreases. Therefore, growth again slows down. Due to what? Limited supply of nutrients. This phase is called as a... What is this phase called as a stationary phase? What is this phase called as a stationary phase? This stationary phase is also called as a saturation phase. What is this phase called as a saturation phase? It is also called as a senescent phase. Which phase, sir? Senescent phase. Is this statement okay? Right? Therefore, growth again slows down. Why? Due to limited supply of nutrients. This phase is called as a stationary phase or saturation phase or senescent phase. Is this statement okay? Once you see here, sir, in most of the systems, initially growth is slow. That phase is called lag phase. Later growth became fast due to geometric growth. That phase is called logarithmic phase, log phase or exponential phase. Then after, growth again slows down due to limited supply of nutrients. This phase is called stationary phase or saturation phase or senescent phase. Therefore geometric growth does not continues for long period of time. Do geometric growth continued for long period of time? No. Again geometric growth right changed to what, sir? The geometric growth had slowed down due to limited supply of what? Nutrients. Therefore, geometric growth does not remains for long period of time due to limited supply of nutrients. Due to what? Limited supply of nutrients. Right? Therefore, geometric growth, right? Which growth, sir? Geometric growth. Therefore, geometric growth does not continues. Geometric growth does not continues for long period of time. Does it continues for long period of time? No. Why, sir? Due to limited supply. Due to what, sir? Limited supply of nutrients. Due to limited supply of nutrients, the geometric growth was not continued for long period of time. Is this statement okay? Right? This statement clearly indicates that listen here, in all cases of growth, in all cases of what, sir? Growth. In all cases of growth, right, an exponential increase, declines, and growth rate starts or begins decreasing or decreases. See this statement? In all cases of growth, right, exponential increase. Sir, I am speaking about exponential phase. Exponential phase, growth is fast. Therefore, growth is increasing at an exponential rate. Yes or no? After this exponential increase in growth, what happened? The growth rate starts decreasing. The exponential increase declines because we are proceeding towards which phase? Stationary phase, senescent phase, yes or no? Therefore, exponential increase, what happens? Declines. So growth rate begins decreasing. The point at which this happens, the point at which this happens, that point is called as a inflection. What is that point called? As a inflection point. Inflection point. Is it okay? And this phase is called this phase is called deceleration phase. What is this phase called? As a deceleration phase. Is this statement okay? Right? Sir, first comes a log phase, LOG. First comes lag phase, LAG. Then afterwards, sir, log phase, logarithmic phase. Their growth was exponential. After that exponential increase, then what happened? The growth slows down. It means the growth decreases, yes or no? Therefore, growth rate, what happened to growth rate? The growth rate starts decreasing. The point at which this happens, that point is called as inflection point, and that phase is called as what, sir? Deceleration phase. What is that phase called? As a deceleration phase. Right? Now listen here. Sir, take time on x-axis. What we are taking? Time on x-axis. Time on x-axis. If you take time on x-axis and growth parameter, what, sir? Growth parameter, right, on y-axis. Sir, what is this growth parameter? You can take either, right, size or weight. What, sir? Size or weight, right? Therefore, if you take growth parameter on which axis? Y-axis, then we are going to get a S-shaped curve. What we are getting, sir? S-shaped curve. What curve we are getting? S-shaped curve. This S-shaped curve is also called as a, what, sir? Sigmoid curve. What is this curve called? As a sigmoid curve. It is also called as a grand period curve. Grand period curve. It is also called as what, sir? Grand period curve. Therefore, we are taking time on x-axis and a growth parameter. That growth parameter may be either size or weight. On which axis? Y-axis. Then we are getting S-shaped curve or sigmoid curve or grand period curve. Okay, this sigmoid curve is given by Von Sachs. Scientist name I am writing. What are the scientist names? Are Von Sachs, right? This Von Sachs, he worked extensively on growth. Von Sachs worked extensively on what, sir? Growth. Von Sachs, he worked extensively on growth. Is it okay? Right? Now see this graph. In this graph, right, time is taken on x-axis, right? Size or weight of an organ is taken on a y-axis, right? And when we plot this graph, we got S-shaped curve, that is a sigmoid curve. Initial phase is lag phase, then came what, sir? Exponential phase, right? Then came what, sir? Stationary phase. Is this statement okay? Right, this curve is called as S-shaped curve or sigmoid curve or grand period curve, right? Right, now listen here. Sir, expression. What? Expression for exponential growth. Expression for exponential growth. Expression for exponential growth is W1 is equals to W naught, right, into e to the power of RT. E to the power of what, sir? RT, right? Sir, where this W1 is equals to what, sir? Final size. Final size. Whereas W naught is what, sir? It is initial size. What it is, sir? Initial size. Whereas R is a growth rate. What is this R, sir? Growth rate. Whereas T is a time of growth. T is what, sir? Time of growth. Time of growth. See this one, sir. This is expression for what, sir? Exponential growth. Expression for exponential growth. Sir, this expression for exponential growth is also called as a law of compound interest. Law of what, sir? Law of compound interest. What it is called as law of compound interest. Is it okay? Right. Therefore, expression for exponential growth, nothing but law of compound interest, right? Now, sir, here W1 is equals to what, sir? W naught into e to the power of RT. Whereas W1 is equals to final size, W naught is the initial size, whereas R is what, sir? Growth rate. R is what? Growth rate. Here it is relative growth rate. R. Here it is what, sir? Relative growth rate. Relative growth rate. Here this small r stands for what, sir? Relative growth rate. And also measure of ability of a plant, ability of a plant to produce ability of a plant to produce what, sir? New materials. Ability of a plant to produce new materials called efficiency index. Efficiency index. Is this statement okay? Listen here, sir. Here small r stands for growth rate, no doubt. In this case, this small r stands for which growth rate, sir? Relative growth rate. Sir, this relative growth rate is also measuring what? Ability of a plant to produce a new plant material. Ability of a plant to produce new plant material. What it is called as efficiency index. What it is called as, sir? Efficiency index. It is called as efficiency index. Is this statement okay? Right? Now listen here. Sir, S-shaped curve, that is a sigmoid curve. Yes or no? What it is, sir? Sigmoid curve shown by all cells, tissues and organs of a plant. Sigmoid curve shown by all cells, tissues and organs of a plant. Sir, sigmoid curve is a character. Sigmoid curve is a character of what, sir? Living organisms. What is a character of a living organisms growing in a natural environment. Growing in a natural environment, growing in natural environment. It means what living organisms they are naturally growing in an environment. Such living organisms shows which curve, sir? Sigmoid curve. Such living organisms shows which curve, sir? Sigmoid curve. Is it okay? Right? A question is given in your textbook. What kind of curve can you expect in a tree showing seasonal activities? What type of curve can you expect in a tree showing seasonal activities? Sir, that curve is a sigmoid curve. What curve it shows? Sigmoid curve it shows. But not a typical sigmoid curve. Not a typical sigmoid curve. It means it is showing sigmoid curve, no doubt. But is it the standard sigmoid curve that was shown by other organisms? No. Therefore shows sigmoid curve but not a typical sigmoid curve. Is it okay? Right? Thank you.